In this video, we are going to revisit the problem of solving triangles. We have already seen how to solve right triangles. So now we will look at triangles that are not right and two tools, the law of sines and the law of cosines that we have. The law of sines will be covered in this video, the law of cosines in another. Let's go look at some triangles though. Triangles can be classified in two groups, right triangles and oblique triangles. Right triangles are the ones that have a 90-degree angle, represented by this little box in the corner, while oblique triangles have no 90-degree angles. Recall if you were asked to solve a right triangle problem, then the tools you have available to you are the angles tool, which says the sum of these two interior angles will always be 90 degrees. There was the Pythagorean theorem, which related the sides of our triangle, and the three trig ratios, sine, cosine, and tangent, as I've represented here using SOHCAHTOA. For oblique triangles, we have a different set of tools. There's still an angles tool, which says the sum of your three interior angles is 180 degrees. This tool is great because if you ever know any two angles in your triangle, then you can find the third one. For example, here I could find gamma by saying it's equal to 180 degrees minus the angle alpha minus the angle beta. Again, this tool is great because if you ever know two angles, then you really know all three angles. The other two tools that we have for oblique triangles are the law of sines and the law of cosines. Which tool you use depends on which information is given in the problem. For example, if in your problem you are given an angle opposite side pair, then you know you have a law of sines problem. An angle opposite side pair might be this angle alpha and its opposite side A. Or it could be this angle beta and its opposite side B. Or it could be this angle gamma and its opposite side C. It wouldn't matter which angle opposite side pair you have, but if you have an angle opposite side pair, then you know you have a law of sines problem. While the law of cosines, well, this is going to be used if you don't have an angle opposite side pair. I'm going to cover the law of cosines more in another video, but at least now you know when you'll have to use it. Let's look more at the law of sines. What does it say? Well, the law of sines says that if you have a triangle with angle opposite side pairs, alpha A, beta B, and gamma C, then the following ratios hold and are always equal. To use the law of sines, we must know three pieces of information, including an angle opposite side pair. For example, if you're given angle alpha and opposite side A and maybe angle beta, then you can use this portion of the law of sines to figure out what this side B has to be. Similarly, let me erase this. If you know an angle alpha and side A and maybe side C, then you'll be able to use this portion and this portion of the law of sines to figure out what angle gamma is going to be. It won't matter which two components of the law of sines you use, but you'll pick which two you use depending on which information is given. Now, there are a couple scenarios that we have to consider when using the law of sines, depending on what information is given. And it's right here. If you're ever given in your problem one angle and two sides, then one unique triangle can be found for that information. However, if you're ever given one angle and two sides, then caution must be taken because 0, 1, or 2 triangles could result from the given information. It is for this reason that this is sometimes referred to as the ambiguous case. I'm going to look more at the ambiguous case in the next video, but take caution when looking at this one. I hope this was helpful.